Hello everyone, in this video we are running the examples in the chapter in-network compressed sensing of the ComNets book. We are assuming that everybody is already familiar with how to run the ComNet simulator and how to use it, and that the environment is already set, and we are currently in the directory ComNetsMU /app/in-network compressed sensing, and we would like to start with the examples. So first of all, we have to generate the compressed sensing input, and then we have to build the Docker container using the commands, the following commands. Generate seed Python file where we are creating our dictionary, and we are anticipating how much would be our mean squared error if we choose to use a dictionary in this case. And second step would be a sudo bash, and then we build the Docker container. And in this during this step we are generating we are building the Docker container. We obtain the dictionary that we could use throughout the example, or the examples we would like to execute, and this would be stored and ready for use later. So please remember that the execution of the last two commands have to be repeated when some of the parameters are modified, especially when we want to change the data sets. And put in mind that within this example there is a set of sensor network readings that are accessible, and you can vary each time the choice of the data that you would like to play around with. Okay, so now we are going through the first example, where we have a very basic point-to-point network scenario. Here the sender has a set of 100 samples, and each containing 80 temperature readings that we would like to compress into 40 measurements each and send to a receiver, which in return will reconstruct the original data using the reconstruction algorithm discussed in chapter 10, what we call orthogonal matching pursuit algorithm, the OMP. But first of all, we are running like here in this step we have the option of either running it using a discrete cosine transform that has been related to temperature readings in the literature. That's why we opted to use it, or we use the dictionary that we discussed about previously, that we prepared before we start running the example. Okay, so let's get back to our first example that we want to run here, and we go for then we specify we have one sender for the topology. Our choice is the DCT transform, and we execute it. Now the connection has been established, and we are waiting for the receiver to reconstruct the data, and there you could see finally that the data has been reconstructed with a certain mean square error of 0.031. Okay, so now we go to the case where we would like to try we would like to change the sparsification mode, and we would like to try the trained dictionary that we had earlier, and we use the command sudo and here topo 1. Connection has been established, data has been transmitted, and now we are waiting for the sync to reconstruct the temperature readings, and we are going to see the MSE that we are creating when performing this type of compression and using the OMP algorithm at the end. And here you could see that for sensor 1 we obtain 0.18 MSE when we use our trained dictionary. Okay, so now we move to another case where we would like to have a what we call cluster-based topology, where basically we have a set of senders, each of which are trying to compress their readings and sending to the receiver, which tries to reconstruct all the data that has been sent from all the sensors. And note here that this framework can take up to 16 nodes for the cluster-based topology. And here, for the sake of clarity, we will just, for example, try to run for, let's say, four sensors. But first of all, we would like to go back to perform the first step to clear everything that we have run before and start clean from zero. So we go and run Python generate seed, and then we go for sudo bash and we build the Docker. Okay, and now we will go back again in using the same command we got earlier when we wanted to show the results when performing the DCT transform as a sparsification method. And here we have we could go for 4 sensors and DCT. We could see the connection established. We have here 4 nodes transmitting. Data is being compressed and sent into the sink, and then the sink trying to recover the original data. And once reconstruction is done, connection is closed. But let's scroll up and show the results we obtained, the mean squared errors for each of the data or values of the temperatures that we previously sent from sensor 1 until sensor 4. And you could see the errors that could occur due to the type of compression that we are performing. And finally, we run the example where we are using the trained dictionary for a topology with four nodes.